Right, our level the reactions of haloalkanes. Haloalkanes, it means now to level la moloring renale a reactant already renale a carbon that are bonded to halogen group, so it can be Br, it can be Cl, it can be iodine, and then it can be a fluorine, but normally we use the bromine and the chlorine that are bonded to the carbon. So already our haloalkane one of the two or three, but it means there must be a halogen group. So Sonjo must are a halogen group compound, or the atoms, which are bromine, chlorine, and fluorine, and the iodine. Right, so in a reactants, we're going to get that alkane, then it will react with some other things. So let's start with this number 1 here. So they say it can cause, from the reaction of this, we can cause an elimination. So if you do elimination, level rotia haloalkane, and then eliminator. Eliminator, of course, in every elimination we must come up with a double bond. The product, the double bond, which is something on the right hand side. So we will double bond, then it shows we have eliminated from an alkane or haloalkane to this one. Right, let's get into cells. So this is our haloalkane. Haloalkane why is alkane? It means we have single bond between the carbon atoms. Here come single atoms ready one. Then halogen or group number 7 here. Br halo. Then now this halogen haloalkane is an reactale NaOH. Now this NOH, which is a strong acid, or eliminate also revel ebe the condition. Let's get condition. Condition is concentrated strong base. This is a strong base, not acid. This is a strong base. Then, but is strong be concentrated, because it is strong, yeah, but dilute. In nature is a strong base, but we can make it more concentrated, or we can dilute it. So if you use a concentrated strong base, which is NaOH, KOH, the lithium hydroxide, then we're going to use also a heat to run this reaction. Then, but the important part is very concentrated. So if you have concentrated, or too much, there are more particles, then can create a separation easily of the atoms or the bonds. So that's why we also need some heat. Then that's when we can react with this base. Then now still with the major products. Here major products. Now on this major products, we eliminate on carbon number 2. Can you see that we are going to eliminate Br on carbon number 2, and then eliminator the hydrogens. So here's the rule. How do we eliminate that? Some the number of carbons 1, 2, 3, 4. 1, 2, 3, 4. Then it's fine. But when we eliminate, some eliminate Br, and then actually Br only one bond. Then break a bond musonji refer 2 bonds. So because what if it's a bond, that's we have something like from 2 different things. So remember in grade 11 cross and dot, showing that these are from different atoms. But now when we combine them, we just use a dash. So that there are 2 bonds here, then when we break them, they must give 2. Then that's what we have. Now, para remove a guy on this structure because who now to zama B R to zama, but I want H is one guy. They say on the major product, the one where the H atom is removed from the carbon atom with the least number of hydrogen atoms. Most substituent double bond forms, e.g. double bond with the most alkyl groups. It's fine. Mobaring ro remover udimo a carbon oloring already onale the least number of hydrogens. Ke mangwe be least number tse dinnyane hydrogen tse dintši a re belele carbon wa mathomo o na le 1 2 3. This one already re tlo o ka se male because re mo tšeela Br. Then but this one, this carbon number 2, carbon number 3 on only 1 2, and then this carbon only 1, the last one number 4 on 1 2 3 4, 1 2 3. So let's just mang between them or carbon number 3 already wo carbon number 2 re mo tšeetše Br ka se mo tšeela bedi re mo tšeela once, then wo one number 3 so re mo tšeele because on less number of hydrogens re mo tšeela o motee, so ra re tlo tšwa this hydrogen and this Br. So the bond is between this one, this carbon number 2 and carbon number 3, and this is what they've done here. Carbon number 1 2 3 4, but 2 and 3 they share that bond more in HBr. Then now carbon re wantšhitše ba, then o swantše ba e formele HBr mo ba yang on, but a re lebelle okay re ntšhitše Br minus then H ke plus. Okay, then now because this is in a solution di dissolve or dissociated di phatlalatše ko di lesane, so ra reng e yo ba Na plus OH minus. Then now because re na le NaOH ka setimele, so ra re NaOH lebelela gore OH o tlo tšeana le mang, o swantše a tšeane le wa positive ka, so this 2 ra wo and this one re ba tlo changeana, ba tlo wa positive o tlo lata wa negative, wa negative lata wa, so OH ke minus o re swantše a tšee positive, ba bonda ba re formela eng, ba ile re formela H2O, and then our form H2O, what about this one, re ba babedi positive and negative, positive and negative they will form NaBr. Then if this is done, so more on lower plus step, so let's do this one. So this one is not there, so this one I want is a baboncha if umadile the minor product, so what will here what about this structure plus NaBr plus H2O, but for now this one is a minor product, so we check a major product of the Markov-Nikov's rule, or hydrogen moving hydrogen mo di carbon o swarane le hydrogen tše dinnyane tša go fetiša ke tše dingwe tše tsela tše dingwe ka ntle le re mo tšeetšeng ena substituent which is halogen group or halogen atom, right? Let's go back to the explanation. Now reactions swantše be haloalkane and a concentrated strong base, so re gatela swantše be concentrated strong base. If on a strong base wa re tlo fa di marks, so swantše gore a concentrated strong base for the elimination reaction. Then the products will be an alkene, a double bond between carbon atoms, then and this will be 2 inorganic. Inorganic go reng a rena a ona mo carbon e bondileng le hydrogen, that will be inorganic. So inorganic a rena ke sodium bromide and the water. that is, and the organic, that will be the alkene. So instead of hydrogen, the carbon bond, if that is an organic. Right, we're done with the elimination of haloalkanes. Right, let's take this one as number 2, which is now we move to the substitution. If substitution from haloalkane, always we're going to produce an alcohol. So let's check the two ways how we can going to produce an alcohol having a haloalkane as a substitution reaction. Now in our substitution reaction, we're running this our haloalkane because of this one bromine. Then we react it with this NaOH again. So this is Na also run OH. So we're going to separator this dissociator by one. So now the condition for this, we're saying for us to have an alcohol, we're also going to have dilute strong base. Or if concentrated. If concentrated, we're eliminating. But if you just that strong base, NaOH, KOH, and lithium oxide, hydroxide, then what are the Roshmishas are dilute. So if you have dilute a strong base, then it means we must also use a mild heat. Then now we're going to substitute. So let's check how the substitution is done. We're running air substitutor. In this case, we're running rather Na separator, dissociator, over Na plus and Br minus. So, and then Br more rather Br minus. And then what do I get? So it's going to be Na, not this one, OH minus. So that's when it dissociates. Then I dissociator, and then Br, nature as working, Br is group number 7 is minus. I mean, let's substitute them. What are more change a more minus or minus? Also, enjoy or minus. Come on, driving dilute. So that's more very minus plus because I substitute or change kind of no change positions. Running more minus also I minus up. So our level more this are still our number of carbons 1, 2, 3, 4. So if there are 4, that is the structure. Mariwalo, mola boluchi PR kimo ke minus. Then also robia umungo minus current to dealing rectification leona, which is NaOH. So our minus KOH is always OH is always having a charge of minus. And then what is happening? That's why mobile veile OH. And then we change channel man or we change channel we substitute le mola le BR. Na mele BR na ya guy. O ya mola ga lo ruchi man, o ya mola ga lo ruchi OH kare. Mo ke ntshi ba no ba change chana o ga re change chana ka madula. So Na ya tsama Na show ya tsama le ya tsama le OH. Now OH re mo jera mmeamo. O raile man, o raile BR. BR o tla kae? O tla mo aswarana le Na. I mean, this is a balanced reaction. Now this reaction conditions dilute, strong base, and the mild heat. Then type of substitution, we call it a hydrolysis. Hydrolysis, that is the type of substitution here. And then what we have, reactant, umasonje haloalkane plus dilute. So dilute strong base or is dilute. And then products, we're going to have alcohol plus NaBr, or if you share potassium hydroxide, KBr, and then if you share then Br one over muchi jeng to zamalo mo wa ba kala mzamai ba tsamale na mo ka sign yawo. Right, now the other hydrolysis still have here a haloalkane because of Br. So this is number 3. And then now we add just directly water, H2O in bonds. Now we add this one. Now they are saying the condition, if you add water, there must be excess water, lots of water, or enough water, or more than what is required of water, because excess and then we still use the mild heat. So we use the heat or medium heat. So that is the reaction condition for when we add water. Then the type of reaction, of course, we call it hydrolysis. Normally the reactions is haloalkane and H2O, which is our water. The results will be alcohol and inorganic substance like the other one. So there are two ways of getting water with substitution. We can add the dilute, a strong base, or we can just add water. And then if we add water from haloalkane, it's not hydrogen, but it is hydrolysis, because now we're substituting. So we revolve Br is minus, so add H2O, H plus, then OH minus. So rather more about Br to do Br because minus, Br is charge of minus, to do OH mo, so more mail OH, then namile Br we guy to zamale H plus, because like a minus, H plus, then O minus, then it means that's why we have H bonded to Br. So positive and negative, they'll bond together. Right, this is the reactions of haloalkanes, where it produces two elimination and substitution reaction. So don't forget, type of elimination here is dehydrohalogenation, because acrylic elimination remove D means we are removing, hydrohalogenation, remove two things, hydrogen and halogenation. That's why I say dehydrohalogenation. Then the type of reactions here for creating alcohol is both of them, they are hydrolysis, not hydration. So when we create alcohol using an addition from alkene is hydration, but here is hydrolysis. Then this is what we have for reactions of haloalkanes.